last topic of design optimization, that is power optimization. So here power optimization is nothing but we'll discuss this based on the digital systems. So we know that the digital system become more complex, so power consumption has become a more significant constraint in the design. So particularly for the mobile battery operated devices such as cell phones, PDAs, nothing but personal digital assistants, and portable media players. So here the important thing is that the amount of power consumed by the circuit directly affects how long the device functions on a single battery charge. So alternatively, how large a battery is required. So this is nothing but power optimization. Okay. So here the techniques used for reducing the power consumption are, so first is, one approach is to identify the blocks of a system that remain idle for a substantial periods during the system's operation and to remove power from those blocks during the idle periods. So nothing but here in the main system there are some subsystems, we call them as blocks. So those blocks need to be removed when they remain idle. So idle means no operation will be performed. So for example, you can take a laptop computers. Here by powering down the network card when the computer is not connected to the network cable. Nothing but, so you have to remove the connection for the network card when we are not using any internet in the computer. So the second approach here is the way of reducing power in CMOS systems is clock gating. So here clock gating is nothing but it is explained in these waveforms. So this waveform belongs to the timing diagram for a flip-flop with a gated clock. So gated clock means it is taken from the master clock, and here, so according to this waveforms, so here we have used a D flip-flop because D is the input, Q is the output, and here we need to store the data in the D flip-flop for a certain amount of time. So at that time we can get it off the clock for 2 cycles. So by doing this we can reduce the power consumption. So here one take care is need to be done. That take care is that, so it is shown here. So glitch on the gated clock due to the poor design. Nothing but here we need to design the functionality properly. If a poor design is there, so then a glitch in the gated clock can appear, and that glitch can cause the unreliable triggering of the component to which the gate clock is connected. Nothing but, as I said, that if the block remains idle, no operation need to be performed. So when there is a glitch like this in the gated clock, so that may trigger this idle systems and start functioning. So you can avoid the poor design so that we can remove the glitch on the gated clock. So this is the second way of reducing the power consumption. So this is about power optimization. Just go through this explanation, it is very simple. Okay, thank you.